So, if traditional macroeconomic models assume millions of tiny firms just cancel each other out, why do we still experience these massive, completely unpredictable economic swings? Let's dive right into this, because it exposes how a fundamental assumption you might have been taught in Macroeconomics 101 is, well, probably flawed. For decades, the standard playbook has been that individual companies don't really move the needle on the overall economy. But if that's true, where do these massive jolts come from?
Welcome to this explainer. Today, we're unpacking a really fascinating paper from the journal Physics A. Together, we're going to explore the hidden mathematical rules governing our business world and see exactly why the economy isn't nearly as smooth and predictable as the textbooks claim.
We've got a ton of ground to cover, so here's our roadmap. We'll start with Part 1, the macroeconomic myth, move to 2, the granularity hypothesis, look at 3, Brazil's top 1,000 companies, before 4, discovering Zipf's law, examining 5, the progress curve, and finally seeing 6, why precision matters. Let's get right into it.
Section 1. The Macroeconomic Myth and Traditional Models. Okay, so traditional macroeconomic theory tacitly assumes a smooth continuum. Basically, this is the idea that the economy is made up of millions of tiny firms. If one has a bad day, another has a good day, and they just cancel each other out into a nice, smooth, predictable bell curve. But the granular theory argues something entirely different. It says that firm sizes actually have fat-tail distributions. That means a few massive players don't just exist, they literally dictate the aggregate health of the entire system.
Which brings us to Section 2, the granularity hypothesis, or the idea of a few large grains. Think of the economy like a giant jar. The old theory assumed that jar was filled with millions of identical, tiny grains of sand. But granularity tells us that the jar is actually filled with a few massive boulders alongside those tiny pebbles. Those incompressible, giant boulders are the real grains of economic activity. When a boulder shifts, the whole jar shakes.
And to understand what I mean by boulders, just listen to these numbers. Get this. Samsung alone accounts for a staggering 14% of South Korea's GDP. In the US, idiosyncratic shocks to just the biggest companies explain about a third of all GDP fluctuations. And in France, it's almost half. These are absolutely crucial stats. They show that when these mega firms stumble or surge, it isn't an isolated event. They generate massive shockwaves that affect the GDP and literally every single smaller firm out there.
All right, Section 3, Brazil's top 1,000 companies and testing this granularity. To prove this isn't just some theoretical anomaly, researchers needed a smoking gun, right? So they turned to the 2015 balance sheets of Brazil's top 1,000 companies. By sorting these companies strictly from top to bottom based on net revenues, they were able to test this granularity hypothesis against actual, real-world data in a massive emerging economy.
Section 4. Discovering Zipf's law and the power law. So what's the actual mathematical rule these massive companies are following? Well, this brings us to Zipf's law, which is a specific type of power law. When a firm's size distribution follows this law with a Pareto exponent close to 1, which in plain English means inequality is highly concentrated at the very top, it confirms the economy is dominated by giants. It proves mathematically that shocks to those top-tier firms will severely impact overall market volatility.
And here is the exact number the researchers found when they crunched the Brazilian data. They calculated the Pareto exponent for Brazil's top 1,000 firms to be exactly 1.070.
Now, 1.070 might just look like some random decimal point, but it's actually a massive revelation. Why? Because the estimated exponent for American companies is 1.059. This tiny decimal is basically a mathematical fingerprint. It strongly suggests that this granular power law isn't just an American quirk. Actually, scratch that. It points to this being a universal economic rule governing how capitalist markets structure themselves, whether you're in North America or South America.
Just take a look at these log-log plots from the study. They compress massive differences in scale into straight lines. You can clearly see the dispersion between a company's net revenue and its rank, with that straight line perfectly tracing the downward slope. We're not just talking in abstractions anymore. This grounds the whole theory in hard, undeniable statistical science.
Moving to Section 5, the progress curve and the evolutionary arms race.
The researchers actually found a power law progress curve that fits the data with incredible precision. And why does this happen? Think of it as an evolutionary arms race in the market. It's a classic predator and prey dynamic. Companies are constantly adapting to outsmart rivals. In response, those rivals facing extinction have to counter-adapt. Eventually, a state of stasis is reached where all forces balance out. This constant struggle is what generates highly regular intervals between companies' ranking positions, which forms this exact curve.
Finally, Section 6, Why Precision Matters and the Danger of Rounding Errors.
You might be wondering, so what does this all mean for us? Well, the real-world implications of these exponents are staggering. As you can see, if an economist rounds the Pareto exponent to 1.0, the model assumes the top 1% of firms account for a whopping 99.99% of revenue share. But if they just round it slightly differently to 1.1, the assumed share of the top 1% drops all the way down to 66%, meaning just a tiny 0.1 rounding difference or a slight measurement error can completely distort how we view industrial concentration. If you're a government drafting anti-monopoly laws or industrial policy based on flawed rounding, you are literally flying blind.
So the numbers definitely don't lie. We don't live in a smooth economy of millions of equal players. We live in a granular world dominated by giants whose every tremor shakes the ground we stand on. If macroeconomics has been blind to these massive corporate boulders, how might the big grains in your own local economy be masking deeper volatility today? I'll leave you with that provocative thought to consider the next time you hear economists discussing smooth market predictions. Thanks for joining me on this explainer, and keep questioning the continuum.